So our cosine theta is going to be what? So if sine theta is sine pi over 2 over minus 0, then cosine theta is going to be sine pi over 2 minus theta. Okay, it's going to be the same thing. Okay, go in the opposite direction. So what would tangent be? Tangent theta would be, let's flip it to which one? When it flips, which one does it flip to? This is the different one. This one flips to cotangent, because they got to stay the same. Pi over 2 minus theta. And if it's cotangent, what do you think is going to happen? It's going to flip, and it's going to be tangent pi over 2 minus theta. Okay? Keep those in mind as you kind of go through this process. The other thing you need to make sure of is secant theta is going to be cosecant pi over 2 minus theta, and cosecant theta is going to be secant pi over 2 minus theta. Okay, so those are how you would work the system, work it through. All right? Now let's go through doing a couple problems, making sure we're all on the same page here. All right? And hopefully you're still recording, being able to get something done here. All right, so here we go. So for instance, cosecant theta equals 4 over 3, okay? Find the other 5 functions of that. So what would happen if I have cosecant theta? First off, really quickly, what is cosecant? Another way to write that is what? What's the reciprocal of that? 1 over sine, right? So what would I do? Essentially, sine theta is going to be 1 over 4 over 3. Okay? So therefore, my sine is going to be 3/4. Any questions on that? Now, what would I do next? Well, I put it in here. Cosine theta, 2 squared theta, plus sine squared, right? Theta equals 1. So what would happen? Cosine is going to be, so what would cosine be? Square root of 1 minus sine squared theta, right? What was sine? What was it? What was sine? Right here. 3/4 squared, right? So what's that going to give me? Cosine is, all right, so and go through this process, it's going to give me square root of 7 over 4. So once I have, think about this for a second. I have sine, I have cosine. The rest of them can be found now. Why? Because this is the hypotenuse. This is opposite. This is the hypotenuse. This is adjacent. So I can find cosecant, which I already knew, right? Cosecant. I can find secant. I can find tangent. And I can find cotangent based on the information I have. So this is going to be 4 times square root of 7 over 7. Tangent's going to be 3 over the square root of 7, or 3 square root of 7 over 7, and cotangent's going to be square root of 7 over 3. Okay? So those can be identified quickly and efficiently and easily. Okay? All right, so now what would we do if we have cotangent theta? So if we have cotangent theta in here, we're going to do another problem here. Okay, that's one type of problem. Cotangent theta is 2.25, and okay, so find tangent theta minus pi over 2. So what would we do? Okay, so first off, what would tangent pi over 2 be? Or theta minus pi over 2? Well, that is equivalent to, it's another way to write this is tangent negative pi over 2 minus theta. It's another way to write that. Now, what would I do next? So I take out that negative, right? So I take that negative out. Okay, if I take that negative outside, remember our equation, tangent, if there's a negative inside, right? If I take that negative out, what happens in tangent's case? It takes the whole thing and makes it negative. So another way to write it is negative cotangent theta equals, that's what that equals, okay? That's what it will be. And so therefore it will equal negative 2.25. Okay, so if it starts out here as positive, when I solve it according to this, when I plug it in and solve it according to this, you're going to get a negative answer, okay? Because it's negative in its inclusion, okay? All right, so the next part of the lesson is where it gets a little more difficult, and you're going to have to start learning some of these processes. So I'm going to teach one of the lessons, do one of the problems, then we'll take some time to do some later, okay? Here's one. Tangent theta minus secant theta cosecant theta. Okay, so this one just says we want to put this in terms of sine and cosine. We want to express it in terms of sine and cosine, okay? If we want to do that, what would we do? First off, how would we express this one in times of circle? So it would be sine theta over cosine theta minus, what's secant and cosine? 1 over cosine theta times 1 over sine theta. Now, you can't combine like terms. You can't combine like terms yet, can you? You can't. So what can you do? Well, you make a common denominator. So sine theta, right? And when I do that, what do I get? Sine squared theta minus 1 all over cosine theta sine theta. Okay, because now I have a common denominator and I'm combining the terms on top. Now, what do you think? When you see that, what do you think? You think sine theta minus 1. What's another way to word sine theta minus 1? So, let's think about this for a second. Cosine squared plus sine squared equals 1. Rearrange this problem. I want to plug in for sine squared. Sine squared equals 1 minus cosine squared theta, right? So if I plug that in, what do I get? 1 minus cosine squared theta minus 1 all over cosine squared, or cosine and sine squared, sine. Now, 1 minus 1 is 0, so negative cosine squared theta over cosine theta sine theta. Is that as simplified as it gets? No, I can reduce this, right? So it's going to be negative cosine theta over sine theta. Whoa, guys, what does that equal? Cotangent negative cotangent theta. So what you're doing is basically you're adjusting these, subbing in order to solve. So what you're trying to do is eliminate and solve these functions as best possible, okay? So what I'll do is I'll let you go because this is going to get this lesson could get really, really long really quickly. And so we'll leave it at that for now.